This video is the toolkit that you need to talk about the y-intercept and the rate of change in both tables and graphs. And we'll also end up talking about equations too. So, when you're looking at a table, we'll start with that. You can see here that in this table, the x variable, independent variable, is going up by the same number. It's increasing by 1 each time. Okay? Now, when that happens, you can see the dependent variable, or the y, is increasing by 2 each time. So, as long as the x variable is increasing by 1, then you can use this number here, our 2's, to talk about that being your rate of change. The rate of change is the amount that the dependent variable changes for every 1 unit of independent variable. So if this was our time in seconds and this was our distance in meters, the rate of change would be the distance that this is changing every 1 second, or whatever these other variables are. Okay, so the way we see that in the table is, in the graph are a couple of ways. First, the way we see the rate of change in the table is if you pick any 2 points on the graph. Now, these 2 points come from these points here. The points are just the points in the table. So this point 0, 7 is right there. And the point 1, 9 is right there. So you can see on the graph that every time my y increases by 2, my x increases by 1. So that's a +2, that's a +1. That's where your rate of change on the graph is coming from. Every time my dependent variable increases by 2, my independent variable increases by 1. So your rate of change is how much this is changing every time that's changing by 1. So in this case, it's 2. You can see it there. Okay, now, your rate of change is also called, in a linear situation, the slope. The rate of change and the slope are the same things. You can see here too, every time your x independent variable goes up by 1, your y increases by 2. So as we move on, we'll usually go this way, but you can also go underneath as well to see that. So the other important part, so that is all rate of change, or also called slope. There's another name that we'll give this here in a second. So the other thing that you want to look for here is the y-intercept. So the y-intercept is simply where a line crosses the y-axis. We know that this is the x-axis and this is the y-axis. So you can see that where this line crosses the y-axis is right at this point right here. Okay? That's where they intersect, and it's called the y-intercept. Now, in the table, you can see it because any point on this y-axis has an x value of 0, because you start at the origin and you don't go any. You stay at 0 or on the x-axis, and then you'll go to wherever this is on the y. So you're looking for your y-intercept here in the table when x is 0. So in this case, you can see that when x is 0, y is 7, and it matches up with our point in the graph, the point 0, 7, where this line crosses this y-axis. So now what we're going to do is we're going to put that in an equation. So what this is saying, this table here, is that if I start, that the distance will be, okay, so our race will end up, y will equal, this person gets a head start of 7, so that's their starting value. Sometimes you'll see the y-intercept also be called a starting value or starting number. So they start at 7, and then every time it goes up by 2. So you're going to increase by 2 each time. So that is the independent variable, so you can apply your rate of change to every time. Okay, so in linear situations, this starting number, the y-intercept, just stands by itself. And this number in front of the 2 is our slope or our rate of change. And anytime there is a number in front of a variable, they will call that a coefficient. So the name that you need for that is the coefficient. And that represents, of course, the rate of change or the slope. So just to give you that formal structure of an equation, anytime we have a linear equation, it can be written in this format, generally talked about y equals mx plus b. Okay, so here's the breakdown of how what each of these things are. We already know that x is our independent variable. And y is our dependent variable. So we'll get an outcome of y, in this case distance, based on whatever our dependent variable is, in this case time. So based on how much time someone walked, that's the distance they'll be. So the other part is, I know I have it written here as y equals b plus mx. These two are equivalent to each other. Order doesn't matter when you add, so either will work there. So this b part, you can kind of think about it, it's where we begin. So b stands for where we begin, which in our case, we talked about using it as a start number is where we begin. And in this case, it's on the y-intercept. So all of those things are the same thing. The most mathematical term is the y-intercept here. And then we have our coefficient. The coefficient is simply the number in front of the variable. So m is how you move. It's our coefficient of x, and coefficient just means the number you multiply x by. It's also called our slope or our rate of change, how something is changing each one time.